Hello everyone, welcome to day 65 of Learning Data Science. And where are we? We have completed with our first machine learning algorithm, which is linear regression. Today we are going to discuss about the R square and adjusted R square. So basically, it's a simple topic, and you will be understanding it. Means like it's not something more complicated, but yes, uh, you will understand it. It's not something which is uh, difficult. So what is R square? Okay. So for example, basically, I have a data set, right? I have a data set here. And in my data set, for example, I have, say, one, two, three. I have three features, right? And again, the columns in our data, in our data set, the columns we name as features, right? So we have three features, and upon these features, we were training our regression model, right? For example, this is our regression model, this is our best fit line, and this best fit line is being considered again upon these three features as well. Okay. So for example, let's take these three features, say age, okay, and let's say weight, okay, and let's say here area, not basically area, or you can say the city. Okay, okay. So you have just taken for an example with age, weight, and city. It's not that these only will be the uh, our exact feature needed for training our model. No, it is not like that. I've just taken for the reference, just for understanding, just for example. Okay, so just try to understand here. Um, we are using these three features for training our this for training our this best fit line. This best fit line is being created with the help of these three features, right? So again, uh, what we will do, with these three features, we are predicting the things. Okay, we are predicting. Okay, with the help of age, weight, and city, what will be the following things? What will be the following uh, conditions? And again, it depends upon the business understanding of your model. Again, business understanding means what problem you are solving with the ML model which you have created. So here in regression, you have created a regression model. So what problem you are going to solve? Again, problem here means business problem. Okay. So for example, a client came to you, right? And he is from, say, he's asking that, okay, my this particular product is not being sold much, but my this product, for example, product A, he told that it is being at a good sale, it is a good sale, okay, and product B, it is bad sale, okay. So you have to just give him the model which will just tell him ki, okay, basically you are increasing his sales, okay. And how you are increasing his sales? By creating a machine learning algorithm, by doing EDA, by doing the data pre-processing, you are finalizing the data, you are just telling him the problem, okay. So basically this is the problem, and with the help of this, your business problem will be solved. And the accuracy, that all things, for that purpose only you are creating machine learning algorithm, sorry, you are creating models with the help of machine learning algorithm. So just try to understand what's the basic behind it. The basic behind of anything here means the basic behind the model. So why you are creating such machine learning models, right? Why? Because ultimately your goal is to help the business to grow, right? To just help your clients to overcome certain uh, situations. For example, let's talk about road. So you will check the path holes on the road, okay. So you will just tell him, if he is of the construction client of the roads, so it will help like this. And if you are from agriculture, so basically this will be the land where farming is being there and the crops are yieldier. So with the help of these things, with the help of the data, you are trying to just tell him that what type of crop you should grow in what particular month, what all precautions you should take. Okay. And for example, if you are building some say example, with the help of the drone, you are just trying to minimize the accident which happens due to overgathering. So basically, at the end, deep down, what you are doing, you are solving the problems, right? With the help of an AI, which is again, you use machine learning, computer vision, deep learning, reinforcement learning, LLMs, RAGs. These all things. What are these things? These are nothing but components of AI. So you are using component of AI to solve the business problems, right? So here, this is my data set, and in my data set I am using three features, which is age, weight, and city. And with the help of this, I found out with the help of data pre-processing and with the help of my EDA analysis, that okay, these three features should remain, and upon these features I am training my model, I am creating my best fit line. So what will happen, for example, in future you have to add here new column. In future you have to add here new column. Okay, a new column is being added. So as soon as you will add the new column, as soon as you will add the new column, so what it will happen, it will just, it will increase the efficiency. It will increase the efficiency. It will increase the efficiency. And it doesn't matter whether this particular column makes sense or not. Okay, makes sense in the sense what, for example, there is a hotel data set, right? uh, you are taking a hotel day data set. You are, the problem statement the client came is from real estate business, right? So in real estate business, what you will do, ultimately one column will be of city, right? One column will be of city. Okay, city. Another column, just price. Okay, price. And another column, just take it as for example, apartment size. Okay, apartment size or type of apartment, whether it's a flat, whether it's a duplex, whether it's a bungalow, or anything, a corporate site, right? So basically the first column is the apartment, second column is the price, and the third column is the city or area. City or area which you are looking into, right? So basically these three features detect the sale of your particular building, right? For example, if it's a 3 BHK or 2 BHK, then again, in which particular city it's being located. uh, City here basically means not particularly the city you can take, but the different areas around that city, right? Basically this thing is there. But here, in our hotel chain or in our real estate business, okay, what thing doesn't come, what feature we shouldn't include, right? What feature we shouldn't include, we shouldn't include the age, the gender feature here, right? If it's a gender feature, if it's a gender feature, whether it's male, female, right? So this particular feature would not affect your machine learning algorithms or would not affect your model which you have created. Why? Because again here what you can see, that ultimately the apartment size or the price or the city which you are there, right? It will affect the size of the real estate or the price of the real estate, but the gender will not affect, because whether it's a male or female, right? You can't depict the, okay, this type of apartment is bought by a male or a female, who will live here, right? So these features will not make any sense. But as this feature doesn't make any sense, what R square will do, R square will increase the efficiency. R square will increase the efficiency. So this is the drawback of R square. So this is the drawback of R square. What R square does, R square just increases the efficiency, and it doesn't matter whether the feature matches the conditions or not. As soon as you are adding the new features into it, whether it's one feature, two feature, three features, you are just adding the features and the efficiency will be increased. How it being done? It done by R square. Now, to overcome this problem, okay, there is a adjusted R square. There is adjusted R square. So what this adjusted R square will do? Adjusted R square will, if this new feature, this my new feature doesn't makes any sense, so what adjusted R square will do? It will just reduce the efficiency. It will reduce the efficiency. It will reduce the efficiency. It will not increase the efficiency, just like R square. It will reduce the efficiency if you are adding new features, and that particularly new feature doesn't make any sense, doesn't make any productive for our model which is being prepared, right? So again, if you are adding one more feature here, okay, and if you are adding one more feature here, and in feature you are mentioning locality feature is there, okay. So again, the price of the real estate changes upon the localities. So obviously this will be the good feature for you. This will train the model and it will make more efficient, right? So when we will implement this in adjusted R square, this new feature, it will increase the efficiency. It will increase it, okay. Why it will increase? Because the features which we are using it's making sense. It is productive. Okay, it is productive. So it will increase the efficiency. Okay, so I hope you have understood about R square and adjusted R square. In simple terms, I have explained in just one line, whatever thing I have just told you in this 10 minutes. In one line, I will summarize. R square, R square will increase the efficiency whenever you are adding any new feature. And it doesn't matter that new feature makes any sense or makes any productive for your data. But adjusted R square, what it will do, it will check, okay, whether the new feature is doing some productivity uh, with your data, with your model. So it will increase the efficiency. If it's not productive, if it's not benefiting the thing, so what it will do, it will just reduce the efficiency. So that in a simple term, in a one line, I have told you what's the meaning of R square and what's the meaning of adjusted R square, right? So again, let's talk about the statistical terms, like, right? What will be the formula of this? Right? What will be the formula of R square? What will be the formula of adjusted R square? Right? So again, this is a performance matrix. This R square, this is nothing. This is but performance. This is nothing, this is but this is performance matrix. And again, how we are determining this performance matrix is, okay, let's take, this is my x-axis, this is my y-axis, right? And this is my best fit line, this is my best fit line, and this is my predicted point, this is my predicted point, this is my predicted point, and this is my actual points. These are my actual points. These are my actual points. Okay. So in green, it's actual points. In red, in yellow, it's predicted points, right? So at the end, what we are going to do, we are ultimately calculating the distance of this. What we are doing, we are calculating distance of this. Okay. We are calculating distance of this. That's what we do in the cost function. We calculate the distance, and how do we write that? And what this is called, this obviously this is called error, but this error, what is name, it's called sum of residuals. This is sum of residuals. And how do we denote it? We denote it by y hat minus y. Okay, y hat minus y, and we are doing it square. Okay, and this is the sum of all y hat minus y, and we are dividing it by summation of y hat minus y bar. Okay, basically what's this y bar? This y bar is nothing but mean. So what we are doing, suppose this is my mean line. Okay, uh, this is my mean line, this line is my mean. Okay, so we are calculating distance from this, distance, the points, the distance of point from the mean. So basically we are doing that. Okay, and what will be the formula for r square? The formula for r square will be 1 minus sum of residual, which is this distance, particularly marked in white, not so, divided by sum of SST, sum of total. And how do we denote it? We denote it like this. Okay, so basically the maths behind is this. Now, if we talk about adjusted R square, if if we talk about adjusted R square, so what will be the formula for adjusted R square? The formula for adjusted R square is 1 minus, in bracket, 1 minus R square minus into n minus 1 and divided by n minus k minus 1. So basically this r square is nothing but the, in previous which we have calculated, 1 minus SSR SST. This r square is that. Okay, and basically here what is n? And depicting here number of data points, Okay. And k here is my small value, the small value. Okay. So I hope you have understood the formula and the concept behind it. Okay. So tomorrow, what we'll be going to do, we will be discussing about Ridge and Lasso. Then we will start with logistic regression. Okay. So till then, you can just revise the things which I have explained you. Okay. So see you tomorrow. Till then, goodbye. Take care. Jai Hind.